I think it's this one. And then I will.
Okay, so we are live now on
share.
Facebook.
Oh, okay.
Okay, so good evening and namaste to all. I am Saurabh Kaushal from Smartcircuits Innovation Private Limited, your moderator and host for this particular session. So before starting this session, firstly, I would like to thanks to all our viewers. Yesterday's sessions with Mr. Troy, Director of NASA's Team Innovation Lab, was really awesome. Thanks for associating with us. And yesterday also we have announced the winners, top 100 innovators of a Student Innovation Challenge 2020. So we have already, put the results on our website as well as on our Facebook page, so you can, see your result there. In addition to that, to all our viewers, please like and subscribe as well as share our Smart Circuits Innovation Private Limited page and share this video with your friends, your family members, because this is going to be one of the best session related to alternative research and reality. So we have two very distinguished guests with us today. So please share these sessions with each and everyone so that they can take advantage of this particular session and they can learn something new, from this session. In addition to that, in the description of this particular, video, we have one consent form if you are interested in the robotics and all. So you can fill this consent form. So let's start with this session. Again, good evening to our distinguished guest from India. Namaste to both of you. So we have two guests. One is Dr. Isabel Pedraza, and another one is Mr. Munish Dhiman. So it's a long profile. I'm going to read about the profile of Dr. Isabel first. So Dr. Isabel Pedraza is a professor of the Faculty of Physics and Mathematics of the Universidad Autónoma de Puebla, that is BUAP in Mexico. She is the deputy team leader of this institution within the CMS collaboration of the LHC, that is a Large Hadron Collider at the CERN. CERN is one of the biggest physics laboratory in the world. She is a scientist in level 1 of the Mexican National System of Research. She has collaborated with three of the biggest international experiments for the particle and astroparticle physics, Pierre, Atlas, and CMS. She has done analysis for the LHC experiment since 2006. She led the first Atlas publication on the search for electron-neutron final states at Height Point, looking for physics beyond the standard model. She participated in the discovery of the Higgs boson in 2012. That's really a great thing. She was selected by InTalks in association with TED as one of the 20 young achievers who are redesigning their field of work. In 2014, she was selected to be one of the 30 scientists under 40 that are doing promising work in the area of particle physics and neuroscience by the magazine in the Latin American Science. So she's having a huge, impactful profile. So it's a pleasure, to be, with a part of this session. And on the other hand, we have Mr. Munish Dhiman. Is again a very interesting guy, and I met with Mr. Munish Dhiman last year, and he's doing a really great work in the field of artificial intelligence, augmented reality, which is the need of 21st century. So both are speakers are working in the field of the things which is the need in the 21st century. So Mr. Munish is the founder and the CEO of an internationally renowned emerging technology company, Gesture Research and Elastic. Future tech speaker, researcher, mentor, and a specialist on gesture control, computer vision, artificial intelligence, machine learning, and smart devices, with an industry exposure of around 14 years. He is well known for his contribution to innovation and startup community. Alumni of Global Entrepreneur Program, UK, IBM Smart Camp, mentor at Startup Bootcamp Dubai, Smart City, Accelerator, and more. And he is a part of many like an entrepreneur group like the Champion of Change, a group of handpicked entrepreneurs who work with the Prime Minister Narendra Modi, the Prime Minister of India, and the Cabinet Minister of India to advise on a policy making and startup initiative. So both of our guests is having a really awesome profile today. So in this particular session, I will like Isabel to please share your journey, how you have started, something from school stage till LHC experiment that is called the God particles experiment. And so we are very much interested, and I'm sure our youngster, our students and teacher will be motivated from your story. And I also request Minister Munish Dhiman to please, help me in this moderate section. I mean, you have a good knowledge in this physics and space science, and you can, ask a question from together, from each other. And after that, we will also take a question from our viewers. So let's start, and I ask our viewers to please like, share this video. Thank you. So Isabel, please start with your.
Thank you. Thank you very much. You did a very nice introduction, really. And I am pleased to have met you in 2012. You are also in one this set of fellows that were promising by then, and then it's just this is just a result, right? I mean, you have been, you are here sharing this STEAM profiles to all these young students, thanks to all your careers. So thank you very much. I am pleased to share also the space with you both, and because it looks very interesting, the part of artificial intelligence and then virtuality and so on, that I also want to know a lot. And I want to start telling you that I have the impression I have been in India twice, in 2012 and also in 2018. And I have the impression, I have very, very nice impression from the Indian community. You are very smart. I think the publicity is the smartest publicity that I have seen in many places. I mean, I have traveled around in Europe and also in the United States, of course, in Mexico, very little in South America, but it's just the advertising tells you that you have a way of thinking that goes ahead. I think I'm really happy to have a relationship with Indian colleagues, and so I will tell you how have been my journey. I have been very lucky to know that I wanted to be physicist since I was very young, around 9 years old. I think most of the physicists study physics because they want to be astronomers. They want to, you get like in love with the planets, in love with all the universe. So I was lucky to know that I wanted to be a physicist since I was very, very young. And then in Mexico, you get to the university when you are 18. So for me, there was no other option but to do the exam to pass to do physics. In fact, when you enter to the university, they ask you if you don't manage to enter to the career that you want, what else do you want? And then I said nothing. If I don't enter to physics, I wait. Next year I will do it. And then I was lucky, I entered. And it wasn't as I thought. It was difficult for the young people that start is on the engineering or physics or mathematics careers. I think at the beginning it's a change from the school, and then it's difficult, but it gets worse after. No, it gets better. you will start feeling more comfortable after. So don't be afraid. It's different. It's just because it's different. So you are not used at the beginning. And then I was involved in several projects in physics. Physics is a very open area where you can choose many options for research. So I did some research on optics with interference. I did some research with biophysics, also water molecules, how they attach to, and models. And I did some particle physics also. I was doing cosmic rays. Cosmic rays, I got in love with that. That's why I moved from looking to be an astronomer to be a particle physicist, because the cosmic rays comes from outside. You don't know yet, we don't know yet how they are generated. The one that has high energy cosmic rays, the one that have very high energy, we have a few theories. We have seen some possible sources. Nevertheless, the distribution is more or less isotropic, so they are coming from everywhere. And then we don't have something specific. So that is something that those are particles that are crossing your body like 100,000 per hour. and you don't feel it. Nothing is happening to you, but you are receiving all this radiation. And that got my attention. And from then, I started doing work on cosmic rays that are also particles, kind of particle physics. And then I got the opportunity to go to CERN. How this opportunity came? Exactly. So I was going in the particle physics. I was already in the PhD. I already jumped up to the PhD in this story. I was already in the PhD. I was working in particle physics, and my professor had connection with CERN already with one of the experiments, the CMS experiment. So Mexico had already built for me, we can say all my professor and his colleagues had already this collaboration with the CERN. At that moment, there was a collaboration between Mexico and CERN to pay for work stays at CERN. So I was selected in Mexico to come to CERN. Once at CERN, I met one of the professors that I met before in Cuba and Russia. And then he introduced me to my boss, to my previous boss from Wisconsin. She talked to me and she invited me to work with her at CERN. So I accepted. So how was this? Was the connection. India has a very good connection to CERN because you have a very, connected person, Archana Sharma. I don't know if you, I think you know her.
Yeah.
And then she has been pushing a lot for this connection, this work to bring students to CERN. So there is even a summer for Indian students at CERN. So you have a very high possibility. For the Mexicans, we have less students, 1 student per year. Indians, well, the population is also bigger, but but you have the possibility. There is connection. There are I work with Indian universities, with colleagues from India in one of the detectors. So once you get this connection, there is a possibility to come to CERN, and there are other open possibilities for engineering, for example. You apply and so on. Once I was here at CERN, I got this contact with Xiao Wu, a professor, and she invited me to work with her. I worked with her all my PhD, and then as a postdoc, 2 years more. And then I wanted to again have this relationship with Mexico, so I came back to Mexico as a postdoc, and then they hired me as a professor in Mexico, and then I continue this collaboration. So any student that is like looking for into the science possibilities can come to CERN if they look for the specific topic that they are interested. So once is, of course, one of the experiments, CMS experiment, this compact muon solenoid, where the Indian community is large. And then there are a few other possibilities for engineering that they come 1 year for training computing or engineering in some other areas. There are also summer students that then I think there is also a call every year. Well, this year was canceled, of course, for this situation, but every year there is a call for summer students to come to CERN 2 months and work with the experiments. So this is more or less, it's very fast, and it looks like it was easy. But of course, there is a lot of work involved in this. In this, I was selected, for example, right? And in this, when I had the interview with Xiao Wu, she offered me, of course, she saw something that was positive and that I was going to give good results. I have to tell you that at CERN you work a lot. The journeys don't stop at 8 hours. After working 8 hours, for example, per day, you work more as a student. Of course, you work a lot as students. When we were heading to the discovery of the Higgs, you work like crazy. There were colleagues. I respected really my Chinese colleagues. They were like really working or and not sleeping. It was not. It was impressive, and you get also push for this rhythm of not sleep, well, working hard, working. We had meetings on Sundays, for example. We had to present all the results in our group, Wisconsin group. It was known for having these meetings on Sunday from 1 to 7 p.m. And so you work the whole week, and then Saturday you were working also to present something on Sunday. So it's a moment of your life where you to take advantage of what you have, all the resources, because at CERN you have plenty of resources, not just physically, but also all the people that you have there, they are the experts. And we are doing history. We are writing books. The things that we are doing are not written in books. So you cannot really go and look in the book, what is the method that we are using? No, it's someone that had implemented the method. So you go to his office and ask him, what are you doing? Explain me from where. Of course, there are roots that are written in books, but the actual application is new. You are developing methods. You are developing technology to detect better the particles that you are interested. So it's this rhythm that goes in CERN all the time, and it's impressive how we make it work, because most of the people is paid by their home universities. It's not paid by CERN. So like me, I'm paid by Mexico to come to CERN and work. And then this is like, I could say, well, I will work my 8 hours is what I am paid in Mexico to work like that. And then go home. And no, nobody does that. Everybody does their work that is mandatory in their home institutions, like teaching, like all the bureaucracy that you have, plus the work that you come here to do at CERN. And that is a really high standard work that you are doing. So it's it was like easy. I always say that the minimum that my students and my children, they are very little, but the minimum to be successful is to do what you are asked for. Is the minimum. There is no way that you will not be successful if you do what you are asked for. After, of course, and that is the minimum. You don't even have to do more. But if you do more, then you will be noticed, right? But to be successful in the not in an independent way, but in a team, you do what you are asked for, and you will be just in the right place. That is, I don't know if you have more specific questions, or if it was too short.
Yeah, definitely. I mean, we will love to know more about the, even we are getting the questions also. So I will ask the questions later on. So we will love to know more about the God particles experiment, I mean, which the CERN had done. So could you please, I mean, tell your experience related to that?
Yeah. So what we are doing here at CERN, CERN is the organization or European Organization for Nuclear Research. So for many years, it has been dedicated to the search of new particles, and also technology that is associated with the detection of particles. So we have, in physics, we have a theory that we think everything is made of particles. So you cross the cookie. I have cookies here. You cross the cookie, and then you have these small pieces. And even these small pieces, you can crack them again and again. And then at the end, you will have small particles. And this is a theory. But then, as all the science works, is someone has a theory and someone else has to prove the theory. And why we like theories? Because they work, they can be generalized. So once you have one theory, it works, it helps you to do something else. Like you have the theory of gravity, the gravitational theory, then you know how the efforts that you have to do to build a car, for example. It's you have a law that will tell you what you have to do to have a result. So that's why we like theories. So this theory of the particle physics already helps to many things like detection of cancer, like all the treatment that you do with radiation. It comes with the theory of the particle theory. So there is this theory that tells you that we are a set of particles, and it's not a random number of set of particles. We have a specific 6 leptons, 6 quarks, and then you have 4 bosons. That it's like the chemistry table that you have. So we have a specific number of particles, and you mix them, and then you build everything. You build your the body and everything. So to see, you saw that the small particles of the cookie, they were very small. So you crack them, and then you go to the with the microscope, and then you try to see if the microscope is not enough. You need something more powerful that goes closer and closer to these small pieces of the matter. So the way to do it is like how the electronic microscope works. They hit particles into the molecule, for example, and then you can see what was the result of this heating, right? Where it then hits, then you have the image. So what we do is something similar. We collide particles to look very close to them, and then see the result of this collision. The result of this collision will tell us what particle is it was the origin according to this theory. So I have a small animation.
Sure.
Can I try to share if
yeah.
possible? Let me just okay, there you go. Here is it. I will try to. It says host disable attendance screen sharing.
Okay.
Can you allow me to share? Please.
Let me check.
Sure. Are you lost, Munish? Is it okay?
Let me check with my team. No.
I said if Munish was lost in what I was saying.
Okay.
No, are you following? Are you following?
Yeah, I'm overwhelmed a little bit too. A lot of things. So I was actually, excited to wait for your video.
It's difficult it's difficult to imagine. Right? I try myself to, because I have done like radio interviews, and then it's difficult to try to translate what it looks like, and if you don't see images, right? Yeah. But the idea now, before we see the video, the idea is you have protons, so you take them from atoms from helium. You know that the helium is 1 proton, 1 electron. Mm-hmm. Then you take the protons, and then you make them circulate on a tube of 27 kilometers. The speed, a very high speed, very high energy, and you make them collide in 4 points of interest. We have 4 detectors in 4 different points, and then 2 of these points are the experiments that have general purpose, we can say, and I have worked in both of these experiments. You cannot be in both experiments at the same time because we are competition, like who sees something first. So we make them collide, and then we see how it works. So the protons have the energy similar to a train, this high-speed train that we have in France. So imagine this energy that this train, but in a very little point, like the mosquito point. So it's very very high energy concentrated in one point. Many people at the beginning, before we make the LHC start, was afraid of this, but nothing has happened, and I don't think nothing. I mean, nothing was supposed to happen, and except that we discovered the Higgs. So we do this, and we do this collision several times per second. So we do millions of these collisions, and from this, well, you are related with computing and data and artificial intelligence and so on. So we have millions of collisions per second, and we have to save information. From this information, we have to decide in less than 25 nanoseconds if we will keep the information or not. And from this, we have 3 levels of decisions. One that is online, so in the moment that collision occurs, we decide if we will keep this information or not. And then we have a second level that is offline. You do some reconstruction of the traces, and then you decide. And then we have a third level. And then from there, the result is 1% of all these collisions are the ones that are safe, just 1% of these collisions. And we have collected more than 100 petabytes in the first run. Whoa. Just with 1%. So it's like CDs from the Earth to the moon, if I read correctly. So it's a lot of information that has been distributed from in many places in the world. And then from there, many scientists connect to these different places in the world to analyze the data. And then we have this LHC grid, computing grid, that started before Google grid, just a few months before. But we are like the inspiration. I think I feel like the inspiration for many others that have the money to make it bigger.
Yeah, 100% you are. That's what I said. I was so lost listening to you that I was just looking at you and froze because that's a subject of my interest, and I was just listening and I was waiting for the video. Are you able to?
Oh yeah, Isabel. Now you can check the video.
Yes,
yeah.
yes.
You can
now
share your screen. Yeah.
Okay. Now you can see this. So this is how the tunnel looks like. Okay. The blue one is the one that contains the pipe line where the protons go, and it is cold, so the supermagnets work. It is called almost the absolute zero, minus 273 centigrades. Okay. And then we go with the proton, we run the 27 kilometers, and then we collide in one of these experiments that I was talking about. That the experiment that I work in is 15 meters high and 20 meters long. So it's like a building of 4 floors high. And then from there, we are expecting this big experiment. We are expecting to have the result from these microparticles. So the detector is like an onion, like I can share again this one. Like this one. The detector is like an onion. It has several layers. The layer that is in the very inner part is the more the one that has more resolution. The resolution is smaller than a hair, so the ability to detect particles is very tiny, like very how to say yeah, thin. And then each particle that goes into these detectors gets detected, and then you have like a dots. this particle pass with this detector, this detector, this detector, and then you do like lines that goes, and then you know where the particles were. And depending of which kind of particle was crossing, you have different detectors that are triggered or not. So the electrons get stay in the inner part of the detector, in the green one that you have here, and the muons are like the brothers of these electrons, but they are the same charge, but more bigger, more fat. They go all the way to the red part, all the way to outside the detector, and that helps. I mean, this is a knowledge that we know, that we have on how the particles are interacting. So that's why we can develop particle detectors, and then medicine or instruments that help us to detect different things in the body, for example, right? And we understand this radiation, these particles. We understand several kind of radiation. Yeah. So this is what happened in 2012. Was that we collected one event will not tell you that we discover something. It's not just one event. You have to collect plenty of events that you have to connect plenty of events that tells you that you have seen many times the same effect. And not just that, you have, that's why I said we had two different detectors, one the CMS and the other the Atlas detector, and both of them have to detect the same thing. Because all the experiments, how science work is that I give you the theory, I give you the information about the experiment, and you can reproduce the experiment in any place in the world, and you will reproduce the results. That is like the science procedure. But of course, if I give you the information about the accelerator, I don't think if you have budget to build the accelerator. So what we did is we have one accelerator, but we have two experiments with different people, with different technologies to detect particles. So if both experiments detect the same thing, then it's true. If only one, then is someone that connected, the cables were badly connected. So this is the idea, to have these two detectors. And what happened in 2012 was that we were looking at excess in the data in one of the different, we call them channels of the search. We were looking for electrons that liked to have the reconstructed mass in 1 point, 125. We were looking always for electrons that were liking 25. Well, it's a distribution, it's a curve, right? But they were making a peak there. So that gave us a hint that something was happening there. It was electrons, it was also muons. And then, and before, in fact, the very first plot, it was with photons, the particles of the light. We saw this peak in the photons. So this is what we saw in 2012. We discussed with the other experiment, both of them, we were seeing the same, so something new. And finally, after 30 years of looking, we had our Higgs boson. And then we could close this theory of the standard model. So it's complete. We can say it's complete. Now we know 5% of the universe. We have 95% that we don't know. So dark matter, dark energy, we don't know what it is, and we are still looking for. We are still in the experiment. We are still trying to see if we can produce dark matter. If we can, dark energy, I think no, but dark matter, yes. We are looking for dark matter, and several others things. For example, gravity is not included, but we think that maybe a particle that is causing this related to the gravity, because all the forces have one particle associated. The electromagnetic force has the photon associated. The weak force has a W or a Z associated, two bosons. And then the strong force, the weak one is the one that is responsible for all the nuclear reactions, for all the reactions that are in the sun. You have this weak force, and the strong force is responsible for having the atom together, the nucleus together. You have all the positrons there, and then they are positive, so they must be hitting themselves apart. But you have this strong force that makes them together, and there is a particle associated to them. It's a gluon. So we have particles associated to each one of the forces, except to gravity. We haven't seen the particle that causes gravity, and we think it's called graviton, and we look for it. So we have more than 150 searches, different searches in the experiment. We also look for micro black holes that we haven't seen yet, but then this is it's very interesting. It's fascinating because you have, the theory tells you that if you find this kind of micro black holes, you have multiple dimensions, and then some of the energy goes into another dimension. We haven't seen that, but this is a theory, so it's plenty of excitement for me. And for science, all the new generations have a lot of work. I'm done. I discovered Higgs, so go.
I have a so I have a question from Munish sir. So Munish sir, could you please let me know from your experience as you are working in the field of artificial intelligence, augmented reality, and gesture research, and all this virtual research and all. So how you can collaboration? What is the relation between AI or science or physics? So could you please let us know more about the things, and how students, because right now in India, if we are talking about Indian system, from school stage we have artificial intelligence subject in school from grade 8, right? So AI, virtual, and all these things are the upcoming things. So what do you think about this thing, and please tell us more about this.
Well, first of all, thanks so much, Isabel, for all this information. I was literally, mesmerized by listening all these things. I was so fascinated with everything that you talked. And in fact, this was the case when I was studying. I was in my 9th standard, 10th standard, where I developed a very special interest in science and physics. Physics was my, one of the things that I wanted to pursue, but I was not fortunate enough to take it as a career option. And I in fact, I'll tell you my career path quickly. So what happened was, after pursuing my first love was medical science. I wanted to be a medical researcher. Started studying medical science, and then ended up becoming an engineer because of in India, we have a lot of pressure from the society and from family as well for your career options. So I was kind of in a pressure to decide. I had good ranks in engineering and medical both, and I was supposed to take a decision, and everybody was saying engineering is a good option to go for. I said, okay, it's science, I will go for it. And then eventually I moved from pure science to computer science, and then I pursued my career. It was a wonderful career. I think I made a good decision going with computers at that time, because what you did is very hard. I know what kind of courage it takes to build a career in research, and I really admire people like you doing this. I don't have that much of courage and knowledge to really pursue that kind of career. But yeah, I took computer science as a career, and then I moved to research engineer. So because that was in my instinct, I wanted to do that, and I started thinking, how do we relate science and the things that I've learned in my career, virtual reality, augmented reality, artificial intelligence, all these things. And I started relating these things. The very first result of that was, I pursued these things to create products in the medical science field, because that was something that I wanted to be. I wanted to be a medical researcher. So I started meeting doctors, started telling them what we can do with this kind of technology. I can show you something in 3D in front of you as if it is there. And one of the products that we created, alongside All India Institute of Medical Science, we made a visualizer to help in neurosurgery. So neurosurgery is a complicated surgery where you have to, really perform it with a very good precision. You have multiple medical scans like MRI and CT. But these scans are actually done in 3D. But when you look at it, it's actually a sheet that you look at. It's a plain paper, kind of a film that you place on the screen, which will show you different angles of, let's say you're doing a brain neurosurgery. It will show you different angles of picture that is taken using the CT scanner, but you don't have a holistic view of the brain in 3D like it is. So what we did, we made an augmented reality application alongside them, by which you can put on augmented reality glass and look at the patient head, and you will feel like you are looking inside the head. So how it worked was, it used to pick up the data from the MRI scanner, project it on the patient's head, and show you, as if you are looking inside the head. So that was my very first venture, using our technology to help science to do something. And then, we started pursuing more things. And recently, I had a chance to apply, our technology to physics. So I was a great fan of Einstein, and Einstein was known for his thought experiments. So we'll think that I'm running at the speed of light, and the light is freezing. Right? So that's one thing. He will say that, okay, you are standing on the embankment of a train track, and there's a train going, and there are two lightning strikes together. Right? So he will do that kind of imagination, and all the theory he wrote was basis those thought experiments. He will think and he will write. Now, it's much harder for somebody like me to really think like that, to visualize what will happen when I run at the speed of light, right? I cannot see that. We'll say that, okay, the sun rays are starting from the sun. They are coming at the speed of 3 lakh kilometers per second. And if I start running at 3 lakh kilometers per second, I will see the rays freezing right next to me. Right? So that I cannot imagine that. So what we did, we were working with one of our customers. National Geographic happened to be our customer, and we were helping them on a project. And that was actually about the life of Einstein. And in that, we actually made, and we were actually participating at a science expo in Dubai. And, our task was to bring all these experiments live in front of the students.
Wow.
And we made them wear virtual reality glass. Once you wear them, you will feel like you're standing in front of the sun. There are rocks coming around you, and then you have an experience where you are running at the speed of light. Maybe if you allow, I will share my screen. I'll show you how it looked like.
Yes.
Sure. We have hundreds of questions right now with us. So yeah.
So, can you see my screen now?
Yeah.
Yeah. So this is a galaxy, and you see the lady. She is actually visualizing this. So she's looking at the galaxy. So with our technology, we can actually make people visualize things like this. And then so you can see the beam of light.
Yeah.
Then here comes the sun.
Yeah. Okay. Oh, awesome.
And you see now she has started running. So there were light beams coming around her, and that's the frozen light beam. So if you
That's really awesome.
Oh,
wow.
that's
Wow.
the frozen light beam, and she was actually seeing all these as holograms around you. So,
Awesome.
she can look around and she can feel like how it will be to look at the light beam. Though it's not a very accurate representation, but you get that feeling that you are in the space and you are visualizing the light. So that's something that I started doing to really create visualization for helping students to visualize scientific experiments. And in fact, last year we had done a presentation alongside Smartcircuits, where we visualized different planets as holograms around us. So that so one of the things was galactic center. Nobody really have seen how does the galactic center should look like. So we have shown that visualization, and we were actually helping students to get that kind of vision that what though we are not seeing it ourselves as well, but what kind of representation it will be using the technology. So that's one thing that I keep doing now. And in fact, I was talking to Saurabh as well. We will keep adding more layers to using this kind of technology for students, so that they can have more imagination and a practical experience of things. They can see things which they are not able to reach because right now they are at home, or maybe they cannot travel to Switzerland to have experience of your science experiments. But they can virtually be present there alongside you doing that kind of experiment. They can feel like how it is to be in the lab, though they are not doing it, but it always is very fascinating for people like us, who are more of a student of these kind of technologies, to be at least in the area where you do these kind of experiments, becoming a part of the rocket launches or things like that. Virtual reality, augmented reality is actually can bring all these things to everybody in the world. So that's my vision for the technology I do to help people into research and development. And then there is another angle to this is simulation. If you want to do a simulation of certain physics experiments, the systems are now capable, and with all thanks to the technology that is coming, we can actually do certain physics simulations basis the virtual reality. You can simulate the wind speed, another kind of parameters, and see what kind of results you will get. Maybe they are not 100% accurate, because what is naturally is natural, but you can at least get some idea from the simulations that you perform. So that's another thing that we are experimenting on right now.
That's great. So, Isabel and Munish, we have already around 400-500 questions on our Facebook live stream right now. So let me ask a few questions from you, and it would be great. I mean, if we can give answers in a very brief, because we have a lot of questions, right? So again, to our viewers, please like our page and ask your question in the comment box. And Munish, so first question is from Lavkesh Mandirata. I want to ask, how far we have reached in artificial intelligence? Can we develop a science fiction Jarvis that's shown in Iron Man?
Well, Jarvis to a level, yes, but not 100%. Jarvis was autonomous, and it was able to think more than humans with all the senses that is got. But yeah, we are close to something like that. In fact, if you try, if you're having an Android phone or a Apple phone, you have kind of a Jarvis with you. You can talk to Siri, you can talk to Google, and you can get certain answers very quickly, which you cannot get easily. Like ask Google how many stars are there in the universe, it can tell you, but you cannot. Right? So unless you are a student of space science. So those things are very easy. In fact, there are times when I'm at home and I have a 5-year-old. So if he asks something, I can quickly, and I have a Google Home assistant. If I don't know the answer, I can always tell him that why don't we ask Google, and Google can give us the answer. And it can turn on my lights, play music for me, play videos for me. So to a level, yes, but not 100%. It cannot launch the kind of assaults the Jarvis can do. But yeah, to a level, we are reaching that space, and the pace by which we have grown in past few years, it's very near, and maybe better than Jarvis.
Oh, that's great. Okay. So, Isabel, we have a question from Sneh Nehra. He's asking, how far are we in creating a machine that can touch the speed of light, or can go close the speed, or can go close the speed of light? So we assume that something is going on, or some research is going on this particular thing.
Well, we are already accelerating particles close to the speed of light at CERN. So they are 0.90% of the speed of light is what we are doing. Of course, they get massive. They get massive because the speed. So we are already doing it, and we are already researching on a machine that will be more more powerful, and then you will have another 9 in this 0.99999. But we are already doing it.
Okay, great. And Akshat Kampasi is asking, what is the most recent experiment conducted at LHC?
The most recent experiment is the LHC. Is the biggest, the largest in the world. Is the latest that we have. We are already planning new ones, but still the LHC is the largest that we have right now.
Okay. Shankar Narayan Ghoshal is asking, what is a dark matter?
What is a dark matter? So what we dark matter is the name comes because we cannot see it with the eyes or with the apparatus. So what happens is it comes from the fact that the galaxies spin faster than the amount of matter that they have inside. If we look into a telescope, we count how many stars, how many planets, and then that gives you a speed that they have. But then the speed is, they are doing it faster. That means there is they are more massive, and this matter that we cannot see, we cannot count as with our methods, we call it dark matter. So there is something, there is a massive particle that we are not seeing, or kind of matter that we are not able to see with the apparatus that we have up to now.
Okay. So to all our viewers, please, if you want to ask any question, please write your question in the comment section, and like this page and share this video with your all family members and the friends, and also fill the consent form related to robotic online course. So Munisa, I have a question from Gopi Rajesh Sharma. Will you please explain virtual reality in reality?
Virtual reality in reality is
it's complicated.
Experience of virtual reality, and I'm sure nobody can say that they have not experienced virtual reality. Do you know the best virtual reality we have? The best virtual reality we have is dreams, and nobody can deny they have not seen dreams. So that's the best state of virtual reality, when our brain can actually showcase things which are not real, and we believe they are real. And we get immersed in it so much that we feel that we are actually really doing it. And everybody has seen dreams, I think, right from our childhood, we start seeing those dreams. So we were already aware of having a virtual reality. Now, as I said, we are bringing intelligence in the form of artificial intelligence. The same way, we are trying to, fool our brain with, a few things which our brain feels are real, which are not. Though we are planning to do it for good, but that's the, one of the biggest examples of virtual reality is our dreams. Though now there are multiple examples, like you can have dreams using headsets, you can have dreams using simulators. In fact, companies like BOSS and a few other sound companies are doing sound-based virtual reality, because sound is one of the other sense. So anything, any sensors, any machines that can fit to your senses and simulate some sort of reality is actually virtual reality. And the ultimate aim for virtual reality is to really go inside your head and maybe plug in somewhere and wire itself, so that it can tell your brain directly that you are experiencing something. Once we achieve that, then that will be the ultimate thing. And maybe as our God Krishna said, everything that you see is Maya. So you never know. We are actually seeing some kind of virtual reality, and maybe when our scientists actually figure out that everything that you are seeing, and that's some of the theories, that everything that we see is not real. It's perception. Whatever you see is actually your perception of seeing that thing. Maybe if I have a very sharp vision, and my eyes are like electron microscope, I'll be able to see a very different world than you. So, whatever we are seeing is already virtual, but that's like more of thesis. But for the straight definition, anything that can make your brain feel or your senses feel that they are getting something naturally is virtual reality. So it could be.
Yeah, okay, great. So we have another question, Munish. Can we make a device using artificial intelligence which work for a blind person?
Yes, there are actually a lot of experiments that are happening. In fact, if you look for a video from Microsoft, if you do Google, you will be able to find out a video where a blind man is supported by artificial intelligence, and vision-based artificial intelligence is one thing which is picking up a lot, where the cameras are looking at multiple things, and that's one of the fields that we also work on, vision-based AI, wherein we pick up images from the camera and start making sense of it. So a blind person can actually put on a glass, and that glass can really put some information into his ears. So that's the current state right now, wherein you can receive data from the glasses and hear some information about the scene. So that is already there, and there are experiments further to this, where we are actually pulling in data from the cameras, and those cameras are connected to our nerves through some sort of sensors. And these are all experiments right now. These are not really deployed things. The first one is deployed, but this one is actually part of the experiments, where we deploy the data coming from sensors and from cameras, which are pushing data to the nerves, and those nerves are actually the nerves which are picking up data from our retina, and they are sending information to our brain. So that's the kind of experiments we are bringing. And in fact, not just a blind person. Imagine you are having a supervision. You can see 5 kilometers away. So if you are a soldier and you need a superpower in your eyes, you will be actually enabled with those kind of eyes as well. So that's the level people are thinking.
So Isabel,
Yeah, tell me.
yeah. So I have a question for you, and from Anushka Bansal, grade 5th student. She is asking, does sound travel faster in space?
Well, for the sound to travel, you need air. In the space, you don't have air, so it cannot travel.
Okay. And Siddharth Singh Chauhan is asking, a galaxy shaped like a jellyfish located in the constellation Triangulum, galaxy ESO 137001, looks amazing. Is it? Is not? I mean, he's asking, is there any this type of a galaxies in a space jellyfish like?
In a space jellyfish, I haven't seen any.
Okay.
I think there are several shapes, but I haven't seen anything like that. No.
Okay. I have another question from Munish. Sir, the question is that how students can pursue a career in artificial intelligence? As a CBSE introduced this as artificial intelligence in a school stage. So what's your thought on that thing? I mean, at a school stage, or I mean, how students can learn about the AI?
Well, actually, unlike before, pursuing a career in AI today is much easier, because AI is getting applied to almost all the fields these days, be it from scientific research to your share markets, to your day-to-day works. In fact, e-commerce, everybody's using AI, and if you look at any good company, they have a data science division. So one of the things that you should pursue is, there are two ways to pursue a career in AI. One is actually the AI developers who actually write code and make the programs to work. So if you are inclined towards the technology, then you can pursue that career. You can become a computer science engineer, or an engineer who can write code, because that's one of the mandatory things for doing AI, that's one field that you can pursue. So you can go for any field, but learn some sort of coding language so that you can pursue a career as an AI developer. Another interesting thing is data scientist. Now, data scientist is totally, people confuse it with the AI developer, but data scientist is a little different. He's actually the real brain. He will think about, what kind of data points he will collect, how do we analyze that data, how do we process that data, how the machine will use that data to take decisions, how our mind will mature. So imagine that you are a human, and you have two things. One is the physical brain, and one is your intellect. So intellect is not really a physical thing. So that's actually data science. Everybody, and if you look at people, they come with different level of intelligence. How does that work, right? So that's actually how they perceive the data, how they consume data, how they make sense of it. All those things are actually a part of data science. So maybe you have the best of the computing systems, but unless you have the data scientists in place who will know how to make sense of that data and how to utilize that data, your intelligence will be of no use. So that is one field where you don't really have to be an engineer to pursue that career. You really have to have that kind of thought process, to consume the data and start utilizing it for becoming a data scientist. So that's another field that you can pursue.
Okay, so I have one question from both of you. Shahnawaz Hassan is asking, because one is scientist and another is an engineer. So I have a question from both of you. Does scientists believe in God? Why or why not?
I think it depends. It depends on the scientist. This
Okay.
free. It is not. It's compatible. It's not incompatible. So there is no reason for not to believe or to believe. Everybody believes what they want.
Okay. And what do you think, Munisa?
Well, yeah, that's actually, again, it depends, and it really depends on your definition of good. There are multiple ways to define God. My definition might be totally different from your definition. I believe in God, yes, but what kind of God I believe in and what do I think about God is totally different. I'm not somebody who will believe in a God which I'll find in a temple or at a place of worship. I might say no to it. If you think that doing that doesn't make me somebody who believe in God, that's wrong. I have my own definition of God, and I believe He's there somewhere running the show and maybe doing something great. And I perceive Him as that power that runs the whole universe. So my definition of God is that not really somebody who is giving suggestions or talking something to us. So it's actually very dependent on what do you think of God. So believing in God and thinking what God is, there are two different things. But yeah, it really depends on person to person. Some scientists will go pray before their scientific experiment as well. Some will just go and make sure that they practice a lot. Practicing and making sure they give full concentration to their work is their God.
So Isabel, Satvir Singh is asking, is more energy expanded in generating antimatter than the energy which gets released when formed antimatter react with matter?
I didn't understand the question. Sorry.
Okay. So he's asking, is more energy expanded in generating antimatter as compared to when antimatter formed?
Expanding antimatter. Then I think we are doing experiments for antimatter. So the energy is less. I think there is no expanding antimatter. We have difficulties to get it capsulated because once antimatter interacts with matter, then they disappear. So you don't have antimatter anymore. So we have already difficulties just to get few small pieces of antimatter. So now the expanding is not yet. We are not building a lot of antimatter. There are very little of antimatter.
Okay, so one student is asking, we have seen in so many research paper or some papers that you people have searched the alternative universe. Is it true?
Um, we don't know. I mean, there are theories, as I said, there
Oh,
are plenty of theories, but we have to prove them. And then we haven't done any experiment to prove them yet. And then we don't know.
okay. Okay, so Manisha, I have a question. Uh, Someone is asking, virtual reality plays an important role in medical science as they can imagine the parts very closely. So how it will create a boom in medical industry?
How do we?
Create a boom in medical industry. How it will be a beneficial for the medical industry, virtual reality.
Well, there are multiple ways to, really, visualization is one part where, people struggle to do it, because, I was actually speaking to one of the doctors who is also a professor at one of the medical institutes. And, he said, when we do, uh, you know, bone surgery. So they do implants. They apply plates. So at that time, they have to do a lot of practice. The doctors has to do a lot of practice before they actually go live and start doing something. And that practice doesn't happen on real bodies. They have their own ways of doing it. They will do it on wood logs. So imagine a doctor who have only only drilled onto wood logs, and you are the first person on which he is operating on. You should be scared, right? So virtual reality actually gives them, training is one of the biggest area, where doctors can simulate and practice on multiple scenarios when they are inside in their studies. And in fact, when they do surgeries and other procedures, they can do a lot of practice in the simulations as well. So that's one of the things that virtual reality can enable. If you think about scenarios, we while doctors practice, they practice happy day scenario that they can do this and nothing happens. But when they do the actual surgery, there are a lot of problems that can happen. Something will bleed, something will go out of the way because every body is different. So all those simulations can be showcased to doctors beforehand so that they can get prepared, right? So the simulation is one thing. Another is, right, for normal doctors. I was speaking to a doctor and he said the biggest thing that the doctor do to you is the consultation. Though we don't really pay very good attention to it, we say he's just discussing. But having that discussion right with the patient makes a lot of difference in how the doctor is going to treat you. So learning that conversation practice can also be enabled using virtual reality. And we were speaking to one of the institute for creating virtual reality-based, consultation discussions, and then analyzing what kind of decisions the doctors will take based on those discussions for their practice. So that is another area in which medical science can, VR can help medical science.
Okay, I have, Gopi Rajesh is having a question. Can we achieve the path of immortality in near future with artificial intelligence?
Why not? Yeah. So, and I say why not? Because if I can, somehow make a copy of my brain, I can use it. Or in fact, I can somehow put, something that can keep my brain active. It's not just intelligence; it can actually preserve my intelligence for everybody. Like, if you see Einstein's brain is preserved, though they have done it for a different purpose, but in in near future, maybe we'll have technologies which can really scan your brain, make a copy of that brain, and then take help of your brain's intelligence to take decisions in future. Though it's very sci-fi, and I don't know how far it is, but yes, theoretically, yes, why not?
Okay. So, Isabel, I have a question for you. Student is asking quantum computer, how it will create an impact in coming time or in future, quantum computers.
Well, quantum computers, they have a faster answer, faster processing on the data and also on the operations. So they will allow us to have a much better way to give the data and more data in a smaller computers, and then faster. That will be the impact. And right now, it's an area, a very interesting area, and many things are developing in that way, in that direction.
Okay. Okay, so I have another question. So, Munish, Manish Sofat is asking, can we put memories in human brain from digital signal or in digital form?
Well, if you actually, I was in fact watching a series on maybe on Netflix somewhere. It was about human brain. So, there are a couple of experiments on doing this, and that was more using psychological therapies where they were able to tell people that they did something in past and they believed it. Well, digitally, I've not seen this happening, but you never know, it could be possible. Right now, we don't have those kind of wires in our brain, which can really, put memories. There was an experiment where there were small rats in a cage, and they were actually infused with certain memories because there was a chip which was connected to their brain. And once they were left without that chip, they were actually scared of going to a particular path because they were infused with that kind of memory using some computer program. But yeah, on humans, not yet tried.
Okay, that's so. Currently, we have around 700 questions on our live streaming for both of you. So we will ask the selected questions only, and we'll try to finish in a few, next 10 to 15 minutes. So Isabel, I have a question from Trisha Tagore. She said that I have heard that scientists at CERN have discovered or have a theory that there is a boson called the Higgs boson, and everything is covered in a field called the Higgs field. And I have also heard that scientists at CERN are also trying to reach a temperature of 0 Kelvin and a very, very high temperature called the Planck temperature. Is it true?
Well, is it true that we discovered Higgs? Yes. Is it true that we are covered with this Higgs field? Yes. Then is it true that we are going to the 0 Kelvin? Well, we are working with the supermagnets that are very close to the 0 Kelvin. Yes, going close to the zero absolute. Then the last one was going to the Planck scale. Yeah. That one, no, we are not there yet. I mean, we are trying to make another accelerator that will get us closer, but to go to the Planck scale, we are a little bit far from that. It's we need a lot of much more energy, and that will help us to prove the string theory, but we are not yet in the technology to go in that direction.
So I have another question from both of you, Munish and Isabel. Someone is asking, is there any explanation of God or any supernatural power?
Any explanation of God or superpower?
Or any supernatural power?
Not in science. Not in science. We haven't seen. Not in science. Yeah.
Well, okay. One of the easiest definition is not defined.
Definitely. So I have another question. So Akshat is asking Isabel, how are the proton beams in the LHC accelerated?
Isolated. So we collect the protons from the helium, as I was telling. So we have the proton is positive, and then the electron is negative, and then we just separate them with a difference of potential. So we get the positive and then we collect all the positive, and then we make bunches of them, of this positive, and then we push them in the accelerator with a, like just a positive charge. Is how we do it. It's a very, the story starts with a very little bottle of helium, something like that, and we, from that, we make all this work for a few years. It's a very little bottle of helium that we get.
Okay, so we have another question from Ramesh. Is teleporting is possible? We have seen paper about Japan teleported something. I mean, this question is from both of you. Is teleporting is possible?
Teleporting is something that has been developing, and then there have been few things that have been able to teleport. Is when we say it's teleport, I don't know if people understands that it's not the same particle that is in one place that comes to another place. It's the information that travels. So it's like you have this with this particle, and then the information goes to the other place and builds exactly the same thing with the information. It's not that we transport, it's not the transport. And then this has been already, China has done it already outside the, but it's very little, very, it was a molecule, I think they managed to teleport. So this is something that is going on, and I hope it works so we can travel faster.
Okay. Okay, so the another question is that in the experiment which you are doing in CERN, so is there any scope of a data analysis or a data mining in that?
Oh my God, it's what we do. We do data analysis all the time. We have a cartoon that says artificial intelligence before and now. So we were doing artificial intelligence. We were doing the algorithms to select the data. So that is, we were teaching the machines to select the data and to analyze the data is what we have been doing. It's the definition of a scientist at CERN. Is when Munish said data scientists, we are plenty of them at CERN. It's what we do.
Okay, so one student is asking, Sanjeev Kumar, can we develop a small Earth and start life and study life from beginning?
We are, I think, I start from the beginning.
Yes, study life from beginning. What exactly is the life? Okay.
I probably am not getting the question exactly. We simulate conditions similar to what was at the very beginning in the Big Bang. So we simulate a small piece of what was happening. We do like the conditions, but we cannot start a universe in our lab.
So someone is asking, time travel is possible?
To the future, of course, everybody is traveling to the future.
Definitely. Okay. So I have another question.
To the past, it's forbidden by the law. I mean, by the law that we have, it's like forbidden to come. It's not possible. The equations don't allow you to come back. But apparently, someone found. Well, it's what I know. It's what I know. But it would be interesting and chaotic if we can travel.
Okay. So Manisha, someone is asking, what is the technology behind VR and augmented reality, virtual reality and augmented reality?
Well, there are multiple technologies for VR and AR. As I said, there are multiple kind of sensors which can connect to different sensors. There are headsets which will have displays, and you place it on your head, and they come in front of your eyes, and they simulate that you are visualizing something. So that becomes a VR headset. There are headsets with transparent displays wherein you put on the headset, you still see everything around you, plus some virtual information. Those are augmented reality headsets. There are things which, as I mentioned, from companies like Boss and other sound companies, which can simulate sound around you. So those are another form of virtual reality equipments. Then there are a few companies who are working on putting probes on the brain to simulate, some kind of memories. As we discussed in our previous question. So that was another thing. And I met another interesting company. They are simulating taste. So they will have the same thing, and if you try to eat it, one time it will taste like chocolate, second time it will taste like ice cream. So they're fooling your senses to feel like you are eating something else. So that's there are multiple ways of doing virtual reality. Though the most popular ways are putting on the headset and just seeing something, but that's not the end of the world. There are all the senses will have ways to do simulations and feel or see something which is not real, and those are all part of virtual reality.
Okay. So, Munish, someone is asking, is it possible for you to show something related to AI or augmented reality right now on a screen?
Augmented reality.
Yeah, anything related to AI, augmented reality, or virtual. I mean, someone is asking if it would be great if you can show something like that.
Well, unfortunately, I'm not in my office right now, so I'm not even getting something. But I would have loved to show something. Let me see if I can.
Sure, definitely. In the meantime, I have a question from Isabel. Sarika Singh is asking, can dark matter or dark energy destroy something, or it can be dangerous?
Destroy something? No. I mean, we are living with it. It's part of our universe. So it's not like we can destroy something without manipulating. Once we discover it, it's like we may use it to do something, but we don't know even what it is. So we need to know what it is and how to work with it. So we are living with it. There is no way to destroy. Yeah.
Okay. Akshat is asking, ma'am, what is the metric tensor?
The metric tensor is this is for relativity, so, and then that is what we use in relativity. A tensor is like a vector, but in more with more entries.
So to all our viewers, please stay with us. Actually, we are going to announce something at the end of this session, as we are going to do some international competition with the NASA also, that we will announce later on after this session. So please stay with us. We have a few questions for experts. So Isabel, Krishnamurthy is asking, we can enter in the black hole. Is it possible in near future?
Everything that goes into a black hole cannot go out.
Okay, yeah.
So if you want to enter, well, first we have to travel. But if you want to enter, well, I mean, good luck.
Yeah. So Manish, yeah.
Yeah, I'm just trying to set it up if I can do it. So this is the headset.
Okay. So Isabel, Alam Khan is asking, some people saying there are around 100 and 400 billion galaxies. Is it true?
I don't have the number. There are plenty, but I don't have the number.
Okay. And someone is asking, what is the event horizon?
Event horizon. I think it depends on where are you reading that.
Okay. And what do you think about the parallel universe?
Once I asked to a professor, what do you think about parallel universes? And he told me, if we don't interact with them, I don't care. So yeah, once we interact, then it will be interesting. But if they exist and we cannot do anything to interact with them, so I am not doing some research, unfortunately.
Okay. And what do you think about the gravitational waves?
well, they are there, they exist, and now we are able to measure them. So that is a very proof of very high quality and high quality engineering, to be able to measure very little deviations. So it's a wonderful engineering progress that we are showing with detection of the gravitational waves.
Okay, another question is that can we make a thing which can increase or decrease the size of an object in the future?
I don't see like the movies. I don't see it yet.
So could you please let us know, suppose if any student want to be the part of CERN from India, what are the possibilities in the future? I mean, how they can apply for an internship in CERN, or how they can become a scientist in CERN. So what are the opportunities for our students?
Okay, there is a web that is called CERN Careers. There you have the list of possibilities, and you have for engineering, many offers for engineers, for example, computing also. There are also even human resources possibilities. Of course, there is for the European or the state members, there is it is 95% of the people is coming from these countries, but there is still a possibility for countries like Mexico or India. And then the other one is associate, when you study the university, associate yourself with one of the universities that are associated with CERN, and then that will be easy to do the connection and coming to CERN. Yeah.
So Manish sir, are you ready? Ready with
Yeah,
that?
we are ready. So I'll show you the same thing. You know, I'll show you the experiment from Einstein that we discussed. So we'll have a train track right inside my room. So can I share my screen?
Yeah.
So what you will see right now is the feed coming from this headset.
Okay.
So are you able to see what I'm seeing?
Yeah.
Okay. And now, so this one is actually a gesture controlled device. So I can click on things by doing my gestures.
Okay.
And that's the galaxy. So,
Oh, awesome.
The beautiful thing we can experience is the mysterious. One cannot help but be in awe when one contemplates the questions of eternity, of life, and the marvelous structure of reality. Come, see the world through my eyes. Do not worry about the difficulties in mathematics. I can show you mine still greater. I prefer to think visually anyhow. Thought experiments, so to speak. Let us bring to light some of the very thought experiments that led to my greatest breakthrough.
so this is something that I'm visualizing right in front of me.
Yeah.
Our brain track.
Why do our parents always chide us children for not appreciating our youth? They say we believe it will last forever, when in reality it will pass by us in a split second.
Wow.
A nice sentiment. You and I both know that time comes at different speeds. Or can it? Pretend you're standing on an embankment overlooking a train track. Imagine a train racing by, faster than any train you've ever seen. Now I want you to imagine as the train flies tracks at the same time 100 meters apart. Now pretend that you're standing on top of the train during the exact same scenario. Assuming that the speed of light is constant with the lightning strikes simultaneously. Put yourself on the moving train again and really think about it. Were they simultaneous to you? Of course not, because you were moving towards one and away from the other. But for me, standing still on the event, the lightning bolts were simultaneous. How could the two of us experience the same event differently?
So that was.
That's really amazing. Wonderful. Yeah.
So you could see me. I was actually walking inside the train track, looking around the tunnel and stuff.
Yes.
So you could feel like you are in the experiment, and maybe if you remember our physics class, we were talking about two lightning strikes together. That I think will never happen in our lifetime. We've seen that experiment.
That's really awesome. So Munish and Isabel, before leaving, so you want to say anything to our viewers or to our youngsters?
Well, I want to thank you for the very nice hosting. And then, Munish, oh my God, I love the work that you are doing. I love this last demonstration to see these experiments, as you said, Einstein experiments. Very, for education, it's just amazing because those are the concepts that are difficult to get into your head. And then with this, well, the education is going to be fast. I mean, instead of spending 1 week understanding things, you will spend 30 minutes, 10 minutes to understand something. So I admire your work. And I also have very, I don't know, hope on India. Like I see a lot of development in that area, artificial intelligence, all computing, all engineering. I see that India is just going like a rocket up. And then I see all the new generations. Science will always have like an option for work. I think we are in a period where the science is developing, and then it's one of the areas where you are strong, where you can go and make something important in India and also outside. So I really thank you, Surab, for this opportunity, and I'm really happy for this time that I could share with you.
Thank you. And Munisa, before leaving, I mean, you want to say anything?
Well, it was a wonderful session. In fact, as I said during the start, that I'm more like a student in the class right now with you guys. So I learned a lot, and thanks for all the information that you shared. And thanks for the questions, everybody. They were wonderful questions, and in fact, they were actually brought some good point of view and answers that in fact I also had from the panelists. So thanks. It was a wonderful session, and for the people who are actually looking at this as a advisory and a career exploration session, I will say that going ahead, we have seen a situation that was unprecedented, and now's the time when we actually value research much more than the regular work. You have both the options, and in fact, there is a need for both the things right now. So you should pursue what you like. Everything is important at this moment. Whatever you want to pursue, just pursue it with your full energy and dedication. If you do that, there's no looking back. You will definitely be successful. Just one thing, as Isabel said, the most important thing is you do what you're assigned with. That's the minimum that you should do, and there is no definition for maximum. So you keep pursuing, you keep excelling at what you are doing, and take it to the next level. Challenge yourself all the time. So that's something which is the mantra for going forward. And if you have any questions or anything, you have Smartcircuits, and you can access us as well for any questions after this session or any time that you feel like you need a suggestion. So all thanks to the technology these days, we have people from across the world joining us for sharing their point of views and sharing their wonderful suggestions with us. So the world is very small at this moment. Take a good advantage of that.
So thank you very much. It was really a wonderful session. Even I have learned a lot of things from you today. And so again, thank you very much from Smartcircuits Innovation Private Limited team side. So thank you very much. Stay safe. Good night. Take care. Bye. Namaste.